Okay, we're going to look at what happens when you have variables on both sides when you're solving inequalities. So first off, let's just refresh our memory that when you have variables on both sides, first thing you want to do is add or subtract x's from both sides so you can get them on one. That's the first thing you always want to do. And then you want to add or subtract your numbers and then divide from there. But your first step is always to add or subtract the x's on both sides. You don't have to do it that way, but it is the most efficient way and it can eliminate a lot of mistakes. So just kind of keep that in mind. So let's look at this example. So I have 3x plus 6 is greater than x plus 4. So because I have variables on both sides, and this is a 1x, I'm going to subtract 1x from both sides. That is legal, and it kind of takes care of the fact that I have x's on both sides. Makes my equation easier to deal with. I'm going to subtract 6. I get 2x is greater than negative 2, because 4 minus 6 is negative 2. I'm going to divide by a positive 2, and since I'm dividing by a positive 2, I do not have to switch the inequality. Even though this 2 over here is negative, that is not the one that matters. What matters is this 2 right here, and that's positive. So I'm going to keep it as x is greater than negative 1. If I were to graph that on a number line, I would have an open dot, because it can't be equal, and it would be shaded to the right. So let's test a number to the right and see if it works. So let's talk about what this looks like in your check. So I'm going to use 0 just because it is in the highlighted area and 0 is so nice and easy to use. So 3 times 0 plus 6 is greater than 0 plus 4. I'm going to see if this is true or not. 3 times 0 is 0 plus 6 is 6. Is greater than 0 plus 4 is 4, so that is true. So that confirms for me that I have the right part of the number line shaded. In this example, the right side of the inequality is a little bit heavier, so I'm going to subtract the 2x because I don't want to end up with negative x's. I just like to always subtract in a way that I end up with positive x's. So I get 5 is less than or equal to 2x plus 11. Since I want my x's on one side and my numbers on the other, I'm going to subtract 11, and I get negative 6 is less than or equal to 2x. I'm going to divide by 2. I get negative 3 is less than or equal to x. Now, because we read these from left to right, this says negative 3 is less than or equal to x. But I have to be careful when I go to graph it, because it is not going to be shaded this way, because it says negative 3 is less than or equal to x. And these numbers, negative 3 is not less than these numbers. So what I like to do to help myself out is I actually take this inequality and I switch it around so that the x is first. But then if the x is first, if you were to read it right to left, it actually would say x is greater than or equal to negative 3. So then I have a solid dot, and it's the numbers greater than or equal to negative 3. Now, if you're not convinced, let's do the check. So since negative 2 is greater than negative 3, I'm going to use negative 2 and see if this will be true. So 2 times negative 2 is negative 4. 4 times negative 2 is negative 8. Negative 4 plus 5 is 1. Okay, so I have negative 4 plus 5 is 1, is less than or equal to negative 8 plus 11 is 3. 1 is less than 3, so that is true. So that means negative 2 was true, so it should be in the highlighted area, which means x is greater than negative 3. So just be careful when the x is not first you want to switch it around.